Hello. In this video, I would like to share how to use trigonometric functions to solve right triangles. Trigonometric functions utilize an acute angle within a right triangle to explain the ratio of two side lengths within the same triangle. There are 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. When each are evaluated at an angle theta, a ratio of side lengths is returned. Let's label this triangle ABC and focus on the angle A now. I marked this angle on the interior of the triangle with the Greek letter theta. We must be aware of each side of the triangle and their positions relative to the angle theta. What we call the opposite side length is across from the angle theta. The adjacent side length is next to the angle theta, but not the hypotenuse. The angle theta is formed by the intersection of the adjacent side and the hypotenuse, or the longest side of the triangle, which is always across from the 90-degree angle. Should the angle theta be positioned elsewhere in the triangle, the opposite and adjacent labels would switch, but the hypotenuse would remain the same. The sine function evaluated at theta produces the ratio equivalent to the opposite side length divided by the hypotenuse length. Cosine produces the ratio equivalent to the adjacent side length divided by the hypotenuse length. And tangent produces the ratio opposite divided by adjacent. The other trigonometric functions are reciprocals of the first 3. These come in handy when solving for a missing side length and you'd like to avoid using fractions to determine an unknown result in the denominator of the fraction. Since the lengths of sides in right triangles are not always integer values, the trigonometric functions often evaluate as decimals. We will use a calculator to evaluate our examples in this video, and it is important that our calculator is set to evaluate angles in degrees rather than another angle measurement known as radians. Check the settings in your calculator to verify that it is operating in degrees. My calculator shows the letters DEG here to indicate degrees. It would show RAD if it were set to radians. Now, to evaluate trig functions at several angles, I must enter the angle measure first, then press the correct trig key. In this case, sine of 30 degrees is 0.5 or 1/2. Cosine of 60 degrees is also 1/2. Tangent evaluated at 90 degrees produces an error, which will be discussed further in another lesson. If your calculator is producing different answers than mine, then you are most likely evaluating in the wrong angle setting. Adjust your settings if necessary and try the next three examples on your own now. Record your decimals rounded to 3 places. Pause the video and resume playback in a moment to check your work. Now we can use trig functions and ratios to find unknown side lengths or angle measures in a right triangle. When doing so, 3 parts of the triangle are referenced, 2 of which are known values. In this first example, an angle measure is given. One side length is also given, and another side length is unknown. To solve for this unknown, we must first determine the appropriate trig function. Since the adjacent and hypotenuse lengths are referenced, we can use cosine or secant to solve. I prefer to use cosine since the function evaluated at 52 degrees will equal the adjacent length divided by the hypotenuse length. Simply multiply both sides by 12 to obtain the unknown value x. In the second example, we could use sine or cosecant since the opposite length and hypotenuse length are referenced. I will provide cosecant here, again because we would simply multiply both sides by 12 to solve for x. Please try the next example on your own by first deciding which function to use, then solving for the unknown accurately to 3 decimal places. Either tangent or cotangent could have been used to obtain x. In the final 3 examples, you will notice that it is an angle measure that is unknown. In this example, we can use sine or cosecant since the opposite and hypotenuse lengths are provided. I'll use sine. Keep in mind that these trig functions are not multiplying by theta, so it would be inappropriate to divide the trig function to isolate the variable. Instead, we must apply the inverse of the trig function at a ratio to obtain the angle measure. By pressing the second function button on our calculator, we can evaluate the inverse of sine at the ratio 13 divided by 46. In the next example, the inverse of cosine or secant can be used to determine our unknown angle measure. Evaluate the ratio in the calculator first, then apply the inverse trig command. Try the last example on your own now. Pause the video and resume playback in a moment to check your work. Good luck!